So let's get us started. So let me introduce, it's my great honor and pleasure to introduce Mr. Paul Jung from Excellium. Yeah, go ahead. Oh, you want to use this?
No, I have this one, but well, it's too far. So, hello everybody. So today we will talk about trying to use CTI into a SOC. So just to have a quick view of the audience, who are dealing with trying to put some IOCs into a SOC today? Okay. Who got tons of false positive? Oh, there's a few one only, so you have perhaps more solutions than me. So, I am Paul Jung, so I work in security fields in a couple of decades now. And I work at Excellium Services as an incident responder. My team is in charge of using CTI, we're creating CTI, we're dealing with that, and we provide the CTI to the SOC team. That's what we do basically. So my company is a MSSP security company. We do SOCs mainly, but for a lot of customers. We deal with 45 customers and around 80 CM instances. And that's an additional layer of problems. We have to deal with many technologies which do not inject the CTI into with the same way. And we have a lot of different CMs to manage. And when it comes to a false positive, it's quite complicated because you have one false positive per CM and it's rise a flood of alerts, deadly alerts. It's really, really complicated to manage that. So what we will see today is, well, it's what we have experienced, what we have put in production to give you maybe some ideas to help you to change what you do in your own company. Maybe it could be useful for you and for us also if you have some idea to share. So we will see what we need a different kind of CTI for SOC CM and SOC engineers. We will need what is the limits and so on. Then I will go through all the problem and issues that we have to have activable data. Data that you may collect and put in a CMs without any tons of false positive. And I will show you what we do for TTPs also and IOCs. So the first part. TI is a matter of infrastructure, which means IOCs, IPs, FQDN, and so on. Capabilities, that means, for example, we have now my tree attack framework, which is quite useful for sharing that. But also maybe useful to know what are the victimology, what are the intent of the attacker, and so on. That's the CTI, okay? Everything is the CTI. But there are different people who are using CTI with different needs. For example, if there are some security researchers hunting for a specific group, they need to have a lot of context, they need to have aggregates of infrastructure to have some link in that. If you do some live detection, you need to have vetted information that do not create some false positive. If we are incident responder, again, we have different needs. And that's the things that you need to know. Different CTI is needed for different kind of usage. Of course, you may have the same source, but you need, in my opinion, we need to adapt it to, let's say, the audience of the people that want to do something with. So in a SOC, for us, we need at the IOC level, vetted and qualified ones. We need IOCs that the SOC engineer may trust, that create some alerts, but not false positive, tons of false positive. We need to know what kind of TTPs is used by attackers to be able to improve what we are looking for. And once something has raised, once something was detected, the SOC analyst need a lot of information about these IOCs. If you have a detection, is it a phishing, is it a malware? If it's a malware, which kind of malware? All this information needs to be there for him. So that's the problem. So we provide three things to our SOCs. First, we provide IOC feeds, which are flexible in a way that you will see. You may request, for example, all the phishing, You may request one type of malwares and so on, and with decaying, a lot of information which render you the capacity to have feeds that meet your needs. Then we give them a quick lookup and integration into the SOA to be able to have the full informations once there is a detection. And then we help them to try to optimize the detection by giving them incentive to the detection in terms of use cases. For detection use cases of the CM, we link with the ones that are used by attackers. So, having activable data, that's the funny part. So the first things is always quite easy right now. We have tons of programs, sorry, I said problems, that's a lapsus. You have tons of programs, you may have MISC, you may have entellmq. In our case, we use both. We use MISC firstly for interconnection because it's quite easy to have some community, we share with them. We are using this tool, which is quite easy, and we are able to quickly and easily input and share IOCs. But we use also entellmq. entellmq, it's it's a framework that helps you to collect in a way that you want, and you are able to quickly adapt to a new feed, to a new page to fetch, or even some tweets if you want. It's quite easily. So what we collect is first some groups. We are connected to a couple of groups. We produce by ourselves feeds. We are an incident response team, so after an incident response, we got some IOCs and we input it. We produce also some detection on some malware and so on, so we produce a couple of feeds. We use closed fields, which mean commercial ones that we buy, that you put in. And of course, a lot of OSINT one, the ones that abuse CH and so on, whatever is available in the internet. So that's let's say, the easy part. You may collect a lot of feeds, but then you have a lot on IOC and also a lot of garbage. So everybody has always tried, as seen before. You have problems. How to achieve vettings of an IOC when you receive more than 20K of FQDN daily, for example. How to keep this information? How to keep this information relevant and useful? That's quite complicating. So, first things, you need to clean. There are a few parts of IOCs that are not usable at all. They are dead. And they may create some problems. Here you have two examples. The first one, HTTP, which was issued by National CERT, was a good example. It was quite complicated for us. Because on some devices, we do the detection with a begins with. So if the IOCs match the URL, we don't check all the line, but it checks the beginning of the line and we start with. So if the SQDN is P, which means we have a detection on every website that starts with P, okay? Really complicated in this case. Then you have a couple of other IOC that are simply useless. If you have such kind of things, http://TTPs, you see that a thing was broken somewhere, but you can do nothing. So the first thing to do is to clean the garbage, to be sure that every IOC is the way it should. And you will see that there is a lot of encoding issue and so on. Then you have also the easy steps, the local IPs, the documentation IPs, multicast IPs. It's useless. It's useless. You will do nothing with that. Your local IPs are not an IOC for everybody. So again, remove all these IPs, try to clean this mess, and you have a Python library IP address which manages that. Which knows also already RFC 1918, a lot of IPs, ranges, multicast, and so on. So these two steps are quite easy. Everybody may do that. If you are using MISC for this one, you have also some warning list and so on. So it's not a problem. Then the real problem starts. Confirmations to user need. You have 4 examples here. 4 examples that make sense. The first one was fetched on, I think it was a fish tank. That's a feed from all the fishing. It's a nice one, but if you match the IOC, you have the email of the poor guy which was fished. So in your company, it is a nonsense. It will not happen. The second one is coming from MISC. It's a really good IOC because you know exactly what you will look for, but you can't apply that. Random letter number +5, it doesn't work. It will never work. Then, recently, Google, thank you, added some zip domains. And you may start to see some kind of funny like that. So just the IOC is phishing.zip. Arrobas means that between the schema, HTTPS, and the arrobas, that's the authentication. So that's supposed to be user and password. So if you click on this link, you go to phishing zip. The IOC is phishing zip. And the last one, that's the funny one that you have plenty of times. It's what we say, funny defang. Defang is the way to protect an IOC to be sure that you don't click on it. But there are many tons of different defanging. So for a human brain, it's quite easy to remove them, but you need to do it programmatically, and that's more challenging. So don't hesitate. You need to clean. You need to clean the IOC that you received and to conform the IOC in a way that your CMs or detection may be capable of doing. The other problem that we have 45 customers. Some have proxies, some have proxies with SSL interception, some have only layer 7 firewall. So in this case, again, you have issues. If I take the first example, pastbin/row/some strange random, if you have a proxy with SSL interception, of course, you are able to match pastbin and the full URL. But if you have a layer 7 firewall, you will only have the FQDN. And in this case, you will have a lot of false positive by trying to match only the FQDN. Just imagine bitly, drive.google.com, every URL like that are sometimes IOC, tons of IOCs, but are not usable if you reduce them only to FQDN. So then, after the problem of the limitation of the customer devices, you have the limitation on the CM devices. We operate 5 types of CM, and for some, it's quite complicated. For example, if you have some DGA feed, so domain-generated algorithm, that's URL that maybe don't exist, maybe exist, but have short timeline and days. If you use the feeds coming from a smart researcher, which are able to predict the feeds for today, you come to tons of domain daily. Most of them don't even exist, but some of them are existing and are used by malware. So in this case, you have the problem. That's too much for OCM. QRadar, so what we have, there are QRadar that we have a limitation. For example, 500,000 of FQDNs takes 30 minutes to inject into. So it takes a lot of time. You need to manage that. You have also a big problem, for example, even if you have a customer that do SSL interception, and the customer does have a QRadar, you are not able to match an URL that you have cleaned. Because when you input your IOCs into a QRadar, you use what is called a reference set, which is a hash list. And if you have an URL with parameter of your user, it will not be the same that URL without any parameters. So even if you have a QRadar with SSL interception, sometimes you have to go back to FQDN for connection. And that's quite complicated because you will lose a lot of pertinence, a lot of detection. So for FQDN of the GA, one solution is to reduce the time frame. Okay, we know that it's short, really short. So be short on the IOCs that you input into the CM and try to resolve them. If they don't resolve, most of the time you have no problem. Then you have the remaining issue, the human one. The human or sometimes automated one issues. You may have some, for example, this is an example of one IOC that was found in the MISC community. That's the report. That's the IOC, that's the report, but it was flagged as IDS1. And when you have that, it's quite complicated. So sandbox are also greedy. Sometimes you have the update of Microsoft, which come with, and so on. So again, you may use, if you use MISP, a lot of warning lists and so on. It's quite useful. But you have to deal with that also. And then, not the funniest one, but one which is really complicated. To conform yourself to what we are willing to do. So we manage TLP. We are first member. We are TI also member. So we respect the TLP. Okay? There are many colors. There are some IOCs that we may use for yourself and your customer. Other you don't. And then you have PAP. PAP gives you information of how you have to use this IOC. If you got an IOC which at the PAP red, for example, you don't have to interact with it. And it's quite complicated in a CM, because once it will be detected, you have your SOC operator, which will try to NS lookup, to look at, to show down it. So if you have a red PAP, you have to drop the IOC. So the problem is there. You have to manage with color, because you have IOCs which are into your CM, no problem. Sometimes we have IOCs that are in the CM of the customer. Oh, okay, you have to manage, not red. And then you may have some IOCs that are now in the cloud, if you have some Sentinel devices. So it's not so simple. Adding to this, after PAP, after TLP, you have, for some sources, some NDA. So some company gives you the right to do something with the IOC, but not with every constituency that you had. So that's really a huge problem for us that we had to address, let's say, manually with our own development. So now that we have seen a lot of problems that I think most of you are aware of, we will see the answers that we had tried to put in place, and which seems to work more or less. We still have false positive, there is no magic anywhere, but it's quite better than before. So what we had used, we had designed a database, okay, designed for the SOC, okay, which is able to collect IOCs and to be able to run their IOCs for a SOC purpose, for CM purpose, okay? So first things to understand that you have to make a decision concerning what you are collecting. We collect, here you have two examples. We collect a lot of open source feed. But when you have an open source feed, for example, the thread view, which gives you IP high confidence, it doesn't give you any clue of what is the problem with this kind of IPs. 5? Oh, I need to speed up. So in this case, we have a great problem. No, but 5 is short. You need really to vet what you want to have into, to give the information to the analyst. That's really important. So don't hesitate to drop what is not needed. So our approach is to create a database, simple one, which collects hashes, network, and some computer name and other things. Each IOC is atomic. There are no versions, there are no groups, there are no events. We keep unicity, which means that if we enter many IOCs multiple times, we keep only one information and we keep the source. That's all. Then we do a lot of work. Validation, we check what is bad, good. Enrichment, to apply some information additional to the IP. Confirmation, that's for us really important, we split and so on. And we export the tags. So when we got an IOC, we try to recover it. We try to decode it, because sometimes it's real long code, Python code. You have to get it to ASCII, the way the SIM will see it. And we drop the other things. We tag network information, and we tag what is really important to us, flow direction. We tag if it's an IOC that we need to see it, we will see it when my computer go to, or if it's come from this IOC to me. It's really important. It removes a lot of false positive by doing that. You will remove scanners. We don't care about scanners. Scanner will be from outside to inside. And from malware, it will be from inside to outside. So I am able to extract flow of data in this way only. We split all the URL to be able to have FQDN, to be able to have the path, and we remove the query strings, always, to be able to detect and to not have problems with emails and parameters that will be changed anyway when it came to you. We tag the IOCs with export capacity. So we don't drop anything, but we, for example, when we have a bitly, which is here, bitly, if you have only the FQDN, it will give you tons of false positive. So we tag with a patch, with a field which is named recurrent full path. We tag it, so if you are requiring only FQDN, this IOC will disappear. If you have the capacity to see the whole IOC, you will have it. So it's give you the opportunity to keep the IOC if you have more capacity, if you do SSL interception and so on. We use a lot of blacklists, as everybody do, but what we do, additionally to that, we create our own blacklist. We had telemetry through our passive DNS. So for our customer, a couple of customers, we collect passive DNS information. So last scene for FQDN, first scene for FQDN, the number of times he go in, and which customer go in. So it gives you a good telemetry in a view of where they are going. And then we are able to create our own Alexa list. And you see, I work in Luxembourg, my customers are in Luxembourg, Brussels, and Africa. They don't have the same behavior that people will do at home. So at the left, we have our own Alexa, which is called Maria, which was the girl which have done this development. And you see that, 1 minute, okay. It's complicated. We thought that it's completely different. Then we use a little bit of machine learning for new IOCs. So after removing the Maria list, which is 1,000, not 20, we are using a little bit machine learning to spot some domains that are really used by our customer. So for example, in this example, we do that on the rolling 1 month. When there is a new IOC it's come, we conform to it, and we see in this case that for all the IOCs that we have, 2 are distinguishable, cdn.discordapp.com and bitly.com. In this case, these 2 are flagged as full path only and not only FQDN. We simply killed useless IP. Simply, we remove them. It's useless. IP, it's quite complicated to use as IOC. We only rely on IOC IPs that are really related to some malware. Still a rat, it's time. So, last resort, the human, at the end, the SOC analyst is able to whitelist the things. We don't put all the update to the CM at the same time, only a couple of CMs. Then the walls, it give you more time to white it, and that's all. We are able to fetch data on this way. You see, we have a flexible API which are able to detect and take some IOC without the rest. It allows us to create some different use case for the needs. So we are able to extract lists for phishing, extract lists from common malware, extract lists from rats, which give opportunity for the SOC analyst to be happy and to only extract and have data that is relevant for him, with always giving him the possibility to have the full view of the IOCs. Then my time is out. My slides are not. So I will quickly explain. We do also some retro hunting. So it's quite complicated. You have a lot of IOC where that's coming. From the first day to the last time, IOC will, of course, disappear. That's the problem. It came. It takes a lot of time to be detected, to put in the CM. And sometimes you are fished in the between. So that's why we do also retro hunting by using the passive DNS to see if some IOC based on the vetted FQDN were passing in the past, and that we detect it. We have a lot of remaining issues, and the last switch is the TTPs. For TTPs, quite quickly, we are using use cases that are MITRE attack tags. For example, for the LSISS, we have three use cases possible, depending on the source of the customer. We collect TTPs from ourselves or for external reports, and then we are able to map what is mattering, what is really important to see. And we apply the detection. We be sure, of course, we have a couple of standard use cases that we put to every customer. But then, additionally, we use the MITRE detection map to be sure that we are using the ones that are important. Because you can't put 100 of use cases, it's a nonsense. We put only what is possible. Hopefully I'm finished. Sorry about the time, sorry about the thing. Conclusion, collecting IUCs, that's not the tricky part. Don't hesitate to drop what is coming without any context. It's really important. Drop it. Adapt your data adapt the collection to your data, because if not, you will not match and you will do a lot of work for nothing. If you are using PDNS, or if you are not using PDNS, please do it. It's a great source of information, a great source of things that you may be able to look for. You can't request to your curator to look for 20K of IOC daily, but you can do it with PDNS because it's a lack of small information and you may do that. And always keep the real information for the analyst at the end because he needs it. Thanks a lot. So do we have time for questions?
Thank you, Paul.